Hi everyone. Right, well done on the work you did yesterday. I've seen some really nice work so far that's been sent in. Good work. Right, so Pythagoras Theorem. So yesterday we did loads of experiments on how to find it, what it actually does. And today we're going to be looking at the actual maths and seeing how that connects to what you did yesterday. Okay, so Pythagoras Theorem, please take this as notes in your book. Okay, Pythagoras Theorem, careful about spelling. A squared plus b squared equals c squared. Now you're going to use this all the way through school. Okay, so key thing here is that it only works for right angle triangles. Okay, I've written it in a different colour, you can highlight it, something like that, underline it. Really important, okay, that you know this only works for right angle triangles. Okay, and it allows us to find a missing length if we know two of the other sides. So we're going to practice it in a moment, but this is your key information here, and this is also incredibly important. Make sure it's all written down. Now, the last thing we need to do is make sure we label the triangle correctly. Okay, so the most important part is that C is always the longest side. Okay, the longest side of a right angle triangle can always be found opposite the right angle, and it's got a special name. Okay, it's called the longest side is called the hypotenuse. Okay, and it is important you learn that word, okay, because it's going to come up not only in Pythagoras Theorem but in trigonometry when you do that in year 10. Okay, it's quite an important word there. So C is the longest side and it's opposite the hypotenuse. Now A and B are the other two sides. It doesn't really matter which way around they go. We could have A and B, we could have A and B. It doesn't matter. As long as C is here, the other two can go either way around. Okay, that's your important one. Okay, so there are your notes. They're really important. Now I've got a good few examples of how to apply this. You need to make sure that you get at least two of these examples written out in your books carefully. More if you want. That's you know, can never complain about having more examples. So we've got a triangle here. It's a right angle triangle, and we're told that this side is 3 centimetres and this is 4, and this is x centimetres. Okay, so we need to find out how long this side is. Now the first thing that we do, okay, so step 1, label the triangle. Okay, so the first side I'm going to label is C, opposite here. Okay, now don't panic that there's already an x there. That's telling us that it's our unknown value. It might say x, it might say a, it might say b, and sometimes a, b are really confusing because obviously we're going to use them over here. But different people use different letters in here, okay? And it's just telling us that it's the longest side. As long as you know, that it's the unknown side. As long as you know that the longest side has got to be C for the purposes of your formula, then you're fine, okay? So that's going to be C, and these, like I said before, can be A or B. I'm just going to do A and B like that. Okay, now excuse me. Now what we did yesterday, I'm just going to kind of show you this the long way around and show you why the theorem works. Okay, is we had this shape, if you remember, that looked a bit like this, and you chopped it up and saw oh dear, kind of my writing there, but there we go. So yeah, you cut up these two and found out that they stuck in here exactly. If you were struggling with that, it should have looked a bit, and this is a very, very rough sketch, but like a bit like that, okay, with the 4 pieces tessellated around the edge there. Okay, it looked a bit like that when you put them in. So what we actually found was that these two added together made this one. Okay, and we're also told that a squared plus b squared equals c squared. Okay, that's Pythagoras Theorem there. Okay, make sure you've got that written out and make sure you've remembered it. Okay, so all I've done is on side A I've drawn a square, and the important thing about squares is all the sides are the same length. So to find the area of this square, I'm going to do this side times by this side. Well, if this is A and I'm making a square, this side has to be A as well, doesn't it? Because they're all going to be the same. So the area is A squared. Okay, and the same down here. The area of the square that I make here is going to be B squared, because all sides have got to be B. So B multiplied by B is B squared. And I add them together and they give me C squared. Okay, and we know that because we tried it yesterday, we fit them inside there. Those two added together, those two squares will make C squared. Okay, Now, there's one thing here that you might trip up on, so just listen carefully. If we know, and I'm going to do a little sketch down here, I'll do it over here, look, just as an idea. If we know that the area of this square is, for example, 16 meters squared, okay, that's my square. How would you find out one side length? Okay, a lot of people try and divide it. You must be careful, because we know that to find it, we took, let's say this side is A, okay, we've done A squared is 16. And the inverse of squaring isn't to divide, but it's the square root. Okay, that's really important. So A is actually the square root of 16, which is 4. And that makes sense, because we would have 4 times by 4 is 16. Okay, and it's the same thing here. If we know what C squared is, that's the area of the whole square. To find one side, then we're going to have to square root it. Okay, so that's what this formula here tells us. Okay, so I'm going to plug in some numbers now. We've got A, which is 3 centimetres, so we've got 3 squared, okay, because it's A squared, plus B, which is 4 centimetres squared, okay, 4 squared, equals C squared. Now we don't know what C is yet, we're looking for that one still. So, as always, we're going to just work out a bit at a time, okay? Be really organised with these, make sure you're writing one line below the one line below the other one, okay, in a nice neat line. So 3 squared is 9, plus 4 squared, which is 16, equals C squared. 9 plus 16 is 25, which is C squared. Still, we haven't changed that side. And now I need to square root. So we get the square root of 25 equals C, okay, because that's the inverse operation. And therefore, 5 centimetres is C. Okay, so we found out that this side has got length of 5 centimetres, okay? Now, the more you do of these, you're going to quite enjoy them, I'm sure. They're really systematic. Unfortunately, they don't always work out as beautifully as this, okay? So you're going to need to use a calculator. This is my favourite one because it's just lovely consecutive numbers, okay? You get 3, 4 and 5. It's not very common, okay? Usually you're going to get decimals. So let's try one of those now. Okay, so here we go. I'm not going to draw those squares on each time. I simply drew those just to illustrate what's happening and why it's happening, okay? But from now on, I'm just going to stick to using the formula. If you want to put those squares on, please do, okay? Because it's really worth having something if it gives you a bit of a deeper understanding. So I'm going to do my Pythagoras theorem. I'm going to write it out first of all. A squared plus B squared equals C squared. Okay, and I'm going to label my triangle, really important. So C comes first, there we are, and A and B, it doesn't matter, we could have them either way around, okay? But I tend to always we tend to write left to right anyway, don't we? So A, B. Okay then, so substituting my numbers in, I get 7 squared plus 9 squared equals C squared. 7 squared is 49. Plus 8 squared, 9 squared, which is 81, gives us C squared. So that gives us 130 equals C squared. Okay, now we've got to remember our inverse operation. I need a calculator to do our square root. But there we are, so square root of 130 equals C. And on the calculator, we're just going to, I'll show you there, look. Yours probably is a little bit different to mine. I can't find my calculator that's the same as yours. Can we see that better? There we are. It's this button here, the square root. Okay, so it's the one that looks a bit like the bus stop sign. And the square root of 130. And that tells me it's 11.4. I'm going to round that to one decimal place. Okay, so 11.4 centimetres equals C. And just check if it makes sense. Okay, we know C is the longest side of the triangle. And 11.4 is longer than 7 and 9, and it's not silly, it's not, you know, I've not put 114, that wouldn't work, would it? It'd be far too big. Okay, and if it was smaller than 7 or 9, we know something's gone wrong, okay, because it has to be the longest side. Okay, there's one more, let's try another one. Okay, we're going to try one more like this, and then I've got a couple of slightly different ones, okay, where we mix it up a bit. So, labelling the triangle, we get C over there, A and B. and Pythagoras Theorem, a squared plus b squared equals c squared. So let's substitute those in. We've got 4 squared plus 8 squared equals c squared. That's 16 plus 64 equals c squared. 16 add 64 is 80, still c squared. So the square root of 80 equals c, and that is, let's check, square root of 80, you can see that is 8.94. Now I'm going to round that one to, well, I did the last one to one decimal place, so I'll do the same here. It's actually going to be 9.0 centimetres. Okay, and just, I know that we know that is the same as 9 centimetres, but if I've been asked to round something to one decimal place, and if that's what I'm doing here, I'm going to be consistent and do it on all of them, then we still have to include that 0, okay, because we're expected to give a decimal place there. Okay, and it looks reasonable. Okay, it's bigger than these two. It's not crazy bigger, okay, it's about right. Right then, so they get a little bit different now. Okay, so this time, first of all, it looks a bit different, and all I've done is I've just turned the triangle upside down. We get so used to seeing them like this, okay, and that when we suddenly see one this way up, it throws people off. Don't let it, okay? Same thing, just turned it around, okay? Now, there's another difference here. If I label my triangle, here's C, opposite the hypotenuse, and these either way round, let's go A and B. Okay, this time, I don't know what A is. Okay, so it's a little bit different. Okay, now there's a couple of ways to approach this. A couple of different ways to approach it. First of all, is if we just go back to that first example, here we are, just back to this for a moment. If I had known this was 5 and that this was 4, and I wanted to know this one, okay, this side here, that's me, what I would, if I know these two add up to make this one, then if I know the area of this square and subtract one of these, it will leave me with the other. Okay, so if I know the area of C and I subtract b squared, I get left with a squared. Okay, this is, b was the little one that you chopped up, wasn't it, on your example, and a was the one in the middle. If I subtract all of the b, I just get left with a. Okay, or a squared. So it's a similar thing here. I mean, what we could do is two different ways. Okay, we can carry on with what we were just doing, a squared plus b squared equals c squared, and I prefer this way best, okay, than just substituting what I know. So I don't know what a is, so I'm just going to leave it as a squared plus 7 squared equals 12 squared. Okay, and carry on exactly just as we were doing then. So a squared plus 49 equals 144. Okay, and then what we can do now is actually just rearrange this or solve it to get a. Okay, so the first thing I do would be to subtract 49. Okay, so that would give me a squared equals 95. Okay, and therefore a equals square root of 95, which is 9.7 centimetres. Okay, to one decimal place. Now the other way is, some people prefer to do it this way by remembering a second formula, okay, and some people like to remember that c squared minus a squared equals b squared, or alternatively c squared minus b squared equals a squared. Okay, now if you want to use that, that's absolutely fine. I'm not a big fan of having to remember too many things though. Okay, with this method we only have to remember one formula and we just rearrange it to get to our answer. And this type of rearranging is something that you're going to be getting better and better at over time, okay? So rather than trying to remember 3 different things where you could get them wrong, just remember one, okay? But I'm happy for you to do whichever way you prefer. Let's just do one more and then I'm going to let you try some by yourselves. So this time, again, we already know the hypotenuse. We're actually looking for this side here. Let's do b and a this time, the other way around. So a squared plus b squared equals c squared. Okay, we know a is 15 squared plus b squared, we don't know what b is, equals 23 squared. I'm going to have to resort to the calculator for these. I know 15 squared, I've got that one, that's 225. Double checking it. Plus b squared. Now 23 squared is one I do not know. 529. There we go. Okay, so now to solve, we're going to do 529 subtract 225. Okay, because this is positive. So 529 subtract 225 is 304. So b squared is 304. Okay, and then we're going to do b equals square root of 304, which is, we've got there 17.4 millimetres this time. And just be wary not to try and put millimetres or centimetres squared, okay, because these are lengths that we're calculating. Okay, we're actually working out a length, so it's not a square value. So 17.4. And yeah, that looks reasonable. This side, C, has got to be the longest side. It's bigger than this one. Can't quite see my decimal. There we go. Okay, so I'm going to set you some of those now to have a go at. Let me know how you get on. If you are, depending on how we get on, because we will do at least one more lesson on these, at least. Okay, because we can now start, once we've really got the hang of this, we can start to apply it to more problem solving situations, such as, you know, the very, very traditional ladder on the wall. Okay, so you know, how tall does the ladder need to be to get up to the window, or something like that. Okay, so once we've got the hang of this, we can start to look at the problem solving questions. Right folks, I will leave you with those.